this. Okay, so this is R0, and it's simplifying exponents. And I think I said yesterday, like, we start out this algebra review chapter, and it seems like it's all going to be pretty easy and straightforward, and then sometimes it gets turned up a little bit, gets a little bit pre-calcy. Okay, that's not a word, I just made it up. But it will feel like, ooh, I didn't learn this last year. It's because you probably didn't. It's like a new piece of it. Okay, it's taking it a step further. All right, so properties of exponents. That's where we're going to begin. Okay, these are rules that you've learned many, many times, right? Going all the way back to like Algebra 1. So the first is the product rule. Actually, why don't we just do this? So these properties, anytime I'm highlighting something, it's something that I feel like either you should memorize or something that I find more important, or maybe just like a little tip. Okay, so the product rule is when you're multiplying. So a to the m times a to the n. When you have similar bases, not similar, but the same base, okay, you have to remember what to do with those exponents. What do you do when you're multiplying? You add them, yeah. It's just a to the m plus n, okay? So then we have the quotient rule. So that's going to be like a to the m divided by a to the n. Okay, again, we have the same base. So we have this base of a. We have to deal with the exponents. When you're dividing, what do? Subtraction. Very good, subtraction. So this would give us a to the m minus n. Is the pace okay? Everybody can see from where they're sitting. Good, let's continue. The power rule. Okay, this is when you have like a power to a power. So if I had a sub n raised to the n power. What do you have to do here? Very good, multiply. So this would give us a to the m n. Now I want to do like a little side note here. Okay, so I want to look at, what if we had, this is just continuing on the power rule. So like, what if you had something like a to the m plus a to the n raised to the p power versus a to the m n raised to the p power. So just think about that for a second. What do you think you would do there? And now I'd like you to share with your group. What do you think? Take a risk. If you don't know, it's okay to say, I don't know. I don't remember this. Okay, how many people are comfortable with the one on the right? Like, we know what to do here, right? We have a power to a power, we multiply. So we would get like a to the m n p. Everybody comfortable with that? That feels like the same thing we just did here. It was just an additional variable, right? We just multiply things together. How many people are really not sure on this one? This feels a little bit more uncomfortable. This one is, like, I would say one of the most frequently missed questions in like an algebra situation, okay? You cannot distribute this power. So like a lot of people thought, okay, well, I'll just take the p and I'll distribute it because I multiply and I get a to the m p plus a to the n p. It's okay, I'm already telling you that's wrong. How many people thought that? Don't be shy. Yeah, like if you look around, there's a lot of hands up right now, okay? You're gonna hear me say this all the time. This is illegal, okay? You're gonna get this stamp sometimes on your paper. You're not gonna get offended because this is what I do, okay? This is letting you know, hey, heads up, this is not real math. You made this up, okay? This is not a rule. This is not illegal. We're not doing anything illegal in here or outside of this room this year. That's gonna just be a pact we're gonna make, okay? This is not a thing. You cannot distribute that power, okay? So do not do that. This product rule applies to when you have a term raised to a power, not when you have like a binomial situation. So make a note of this because, again, I'm going to give you some tips along the way. I see this mistake all the time. Don't make it, okay? All right, how about, what if like you have just a? If I gave you that base, what exponent is it? It's just one, right? You have like a to the first power here. If it's not written, it is applied, or implied, I should say, that this is the power of 1. Okay, good. If you have a to the 0, do you remember that rule? When you have anything to the 0 power, what is it equal to? 1. Very good. Okay, always. It doesn't matter what that is. It could be 100 things to the 0 power. You still get 1. Okay, what if you have a fraction? Like, what if you have a over b and the whole thing is to the x power? Does anybody remember what you do here? Teresa. No, but we're going to get to the flipping. Okay, good try. It's a fraction, so something's going on there in the top and the bottom. Anybody else want to give it a try? No big deal if it's right. No big deal if it's wrong. Carter.
Is it a to the x over b to the x?
It is. So Carter, how did you get that?
I just distributed the exponent.
Exactly. We know there's 1 sitting here, right? And so what we just saw is the power rule. We have a power raised to a power. You just multiply those together. The only difference is you have to remember that you have to do it to the numerator and the denominator. Very good job, okay? Now, Teresa, I'm going to get to what you said, okay? So now let's look at that. Let's look at a over b to the negative x, okay? And actually, maybe we should even start out simpler than that. Maybe we should just look at a to the negative x power. Let's start there, actually. I'm going to save this. I'm going to table this one, and let's look at this one first. You are not really allowed to have a negative exponent when you're simplifying, okay? Like, it's not something we like. It's not the form we like it in. So we have to make it positive. So in order to make it positive, what do you do? Exactly. Anything that we have can always be made into a fraction. We just put it over 1. So right now, it's like there's a 1 sitting there. In order to make that exponent positive, you have to flip it to the other place. So right now it's at the top. I'd have to move it to the bottom. This becomes 1 over a to the x. So now if we apply that idea to a fraction, what it said was, okay, well, with a fraction, you have to apply it to both the numerator and the denominator. So this would be like a to the negative x over b to the negative x. And then this is a problem, and this is a problem. So they have to move to the opposite places. We just flip the fraction. So we would get b to the x over a to the x. Questions? How many people feel like, I remember this, I'm comfortable with this? Yes, we're a go. Yes, and then you had a question, Ray.
If that's like the final answer, would you ever just write it as bx minus ax?
No, I want you to write it like this. You're not subtracting. So I see what you just did there. Okay, so you were thinking about the quotient rule. But because the bases aren't the same, you couldn't do that. So good catch. Okay? So yeah, you would just leave it like that. All right? Other questions? Okay, so now we're going to practice all of these rules. Okay, is everyone okay if I turn the page? Should I ask before I turned it? Yes? You're good? Okay. All right, so let's do just a lot of examples here. So we're going to do some of these together, some of these individually, some of these with our group. So simplify the expression. Which feels like a really like generic direction, right? Like that doesn't feel like a whole lot of information, but this is what it means. It means put this in standard form and make sure we have positive exponents. This is something I would probably highlight as well. Like this could be a direction on like the homework, quiz, a test, right? This could just say simplify the expression, but I'm never going to tell you this means put it in standard form and no negative exponents. Like you need to know that, all right? Okay, let's look at this. All right, so let's do this. Negative 2x to the fourth. And that I want to actually compare that versus negative 2x to the fourth. Notice that I have parentheses in this first term and then the second term does not. So with your group, I would like you to talk about what is the difference here? How are these different? Would I get the same answer? What is the answer even you could go to? What would you do first? So talk with each other, share your ideas. Again, if you're not sure, it's okay to say, I don't know. How are we doing? You got it? You know what to do? We're ready? We're moving on? Okay, this is just too easy. All right. Carson, walk me through what the difference is.
So for the first one, since there's parentheses there, you have to distribute the fourth power to f in the parentheses.
Okay.
And then for the second one, it only applies to the x.
Yeah. So like this fourth power is only to the x there. So this is actually done. There's nothing to do here. It is in standard form. There's no simplifying to happen. However, on this first one, we do have to distribute that power. Great explanation, by the way. So this is like negative 2 to the fourth power. This is x to the fourth power, right? Because really what we have here are these invisible exponents of 1. So 1 times 4 gives us 4. Another thing I want to point out is like if you were to put this in the calculator, if you just put in negative 2 and raise it to the fourth power without the parentheses, it's going to spit out negative 16 to you. Okay, the calculator is reading it the opposite of 2 to the fourth. You need to tell it, if you need a calculator, that you need to take negative 2 and multiply it by itself 4 times, therefore going to give you a positive number. Okay, so my final answer on this one should be 16x to the fourth. By a show of hands, how many groups knew the difference? Okay, love that. All right, then let's try this one. If we had 2xy squared in parentheses and then raise that to the third power. This is another example of that, right? We have multiple pieces, all to the third power. So we just need to remember, okay, I have to distribute this power of 3 to all of those terms. So I would get 2 cubed times x cubed times y squared cubed. Now, do I expect you to show that? No. Can you show that? Sure. I'm just showing you my thinking within the notes, all right? Because again, this is like our reference. So that's going to give me 8x cubed y to the 6th. I think I want to do this one next. How about 3d times 4d squared to the 0 power? So this is the first time we've seen this rule come up, right? Is this idea of the 0 power. So I'd like you to ask yourself, what is to the 0 power? What do you see? What is to the 0 power? The 4d squared. Everything in those parentheses is to the 0 power. So that means that entire term is equal to what? 1. This is like a free question on a quiz, right? It's too easy. It's too easy. But we got to recognize that power, okay? So I know that that piece is equal to 1. So this is just like saying 3d times 1. Simple. You just get 3d. All right. How about, oh, no, d comes before e. Okay. So let's try this one. How about x to the negative 3, y to the 4th, over 5, y to the 5th, all to the negative 3rd power. We're going to turn up the heat just a little bit. I'd like you to talk with your group with this. What would you do first? There is not one correct answer for what you would do first. There are multiple approaches to this problem. It is what is comfortable for you. No, please don't have them. Just take it home. I have books in class and I have electronics. Oh, so heavy. So heavy. Okay, so I told you there's multiple ways you could start this problem. Did anybody flip the whole thing from the beginning and make this a positive 3? No one. You can. One person did. You can do that. That's option 1. Did anybody move this x to the negative 3 down first? A couple people. You can. You don't have to. Did the rest of you take this negative 3 and distribute it everywhere? That's what I'm going to do because the majority did that, okay? So that's where we're going to go with it. So let's distribute this. Now remember, this has to get distributed to all 4 pieces. You have to remember that. So I'm going to get x to the 9th y to the negative 12th over 5 to the negative 3rd y to the negative 15th. Okay? Now you have, again, more options. Okay? You could start by saying, all right, these are the same base. I'm going to subtract them. I doubt you did that next. My guess is that you started moving the pieces that were negative to make them positive exponents. Did you do that? So I'll do that. So I'm going to move my y to the negative 12th down, and I'm going to move my y to the negative 15th up. I'm just going to flip-flop them because that will make those exponents positive. I also have to move up this 5. So I have 5 cubed x to the 9th y to the 15th over y to the 12th. It's the only thing that will be in the denominator. There's only one more step to go. At that point, you have to combine these because they're the only two with the same base. You also have to simplify the 5 to the 3rd, which is, good, 125. So 125, x to the 9th, y to the 3rd. By a show of hands, how'd we do? How many people? Actually, let's do this. Thumbs up if you got it right. Medium if you were really close, and then down if not so good. Okay, I'll take that. So for those of you, it looks like there was maybe some small error along the way. For those of you that made the error, is there anyone that needs some clarification, or do you see what you did? Okay, then I'm going to continue. Let's go to E. How about this one? Negative 2x squared cubed times 4x cubed to the negative 1. I want you to try this with your group. So I want you to start with your group from the very beginning and talk it through. What are you going to do as a group?
First, I'm going to distribute the 3 to the first 7 numbers in the parentheses. So, negative 8 x 6.
Got to make a choice as a group. What are you going to do first? What y'all doing first? You're just doing the 3 first. Okay. Are y'all going to do that first? Okay, talk it over. Thank you. Yes.
I got 8 x 6 times 1 over 4x. 1 over 4x divided by 6 is a negative.
This is a tricky one. Lots of steps. Okay.
I just left it, so I just what I just did. So since like I just made it 1 over 4x.
You're there.
Since like when you distribute 4 to the power of negative 1, you just move 1 past negative x. Yeah, negative 6.
Okay, so it appears that most of you took these like as 2 terms and did some distributing of the power. So this would give me like negative 2 cubed x to the 6th. Yeah? How many people started there? And then this one times 4 to the negative 1 x to the negative 3. I'm going to deal with these as individual pieces, right? So like negative 2 cubed is going to leave me with a negative 8. X to the 6th is good. I don't have to move that anywhere. Now, I have 4 to the negative 1 power. I can move that down. I can create this fraction. So now I have 4 to the first power when that moves down. Same thing here. I have this x to the negative third. I can move that to the bottom. I'm just creating this fraction. Once I'm here, I'm comfortable again, right? I can just go ahead and start this division. So negative 8 divided by 4 is negative 2. I get x to the 6th minus 3, which is going to leave me with 3 x's, and that's it. So notice what's happening here. Notice I am taking all of the rules and putting them into one problem. That's what you can expect. That's a level we need to get to. You've done the easy stuff individually. Now we just got to put it together, okay, and make it a little bit more difficult. All right, I just have a couple more. So how about, I think we could fit it here. 125 to the 1/3 power times 5 cubed raised to the 1/3 power. Anyone a little panicked about those fractional exponents? Not feeling like that's really delightful? Or are you doing all right? Lots of fraction work in this class, okay? So got to get comfortable. When you see the 1/3 power, what does it mean? A root. The cube root. Yeah, it means a cube root. This is the same exact thing as the cube root of 125. Remember, the top number is like how many of them there are, and then the bottom number is your root. What is the cube root of 125? 5. So this is 5 here. That's easy, right? This is like 5 to the first. Same thing. When I have 3 raised to the 1/3 power, what does that give me? It cancels out. Or it's like 3 over 3, which is 1. So I get 5 to the first here as well. Same base. What do I do with those exponents? Add them. So I get 5 squared. Do I leave my answer as 5 squared? No. What do I write? 25. There are some basic rules you need to know. Just keep applying them. You're going to try this one individually. So 4 to the 1/3 times x squared y times 4 to the 2/3 times x to the negative first. Notice I have some things that have dots between them. Those are just products, right? I could write these all side by side. It means multiplication either way. We have to be comfortable with different notation. So think about what you would do here. Don't get intimidated by the fact that we have fractional exponents. It doesn't matter. Treat it the same. People reordered this. Like, did anyone rewrite this problem, put things side by side? I did. It makes me comfortable. Because what I'm noticing is I have bases of 4, I have bases of x. So I might start by putting these next to each other so I could just see them easier. I might order this a new way. It doesn't matter. It's multiplication. You can order it any way you want, right? Get the same answer. It doesn't matter. What happens when you have bases that are the same? What do you do to the exponents? You add them. What's 1/3 plus 2/3? 3/3 or 1. This is just 4. X squared times x to the negative 1, you add them. 2 plus a negative 1, or 2 minus 1, they are the same thing, I get x to the first. And then I just have my little y sitting here still. Questions? Okay, so you've made it through your first lesson taking your own notes. It's not that hard, right? It's just different. It's just something to get used to.